So if you heat the water from at atmospheric pressure, the water would experience a rise in temperature from A to B, and B would be the boiling point of water at which is 100 degrees centigrade at atmospheric pressure. If you heat it further, there would be a phase change, which is called as latent heating, and then if you heat it further, there will be superheating. B is the saturated liquid. How do we define saturated liquid or saturated water? Saturated water, if you heat it, it is about to boil. State C is the dry saturated steam. Dry saturated steam means it does not have any liquid water in it, and if you heat it further, it would experience superheating. D is the superheated steam, meaning that it is having a temperature greater than the saturation temperature. So A to B is compressed liquid, B to C is saturated mixture, and C to D is superheated mixture, right? When you change the pressure from 1 bar to 10 bar, that is from 1.1 megapascals to 1 megapascals, the boiling point would increase, the latent heat would decrease, right? And you would find that the steam has to go to a higher temperature for becoming superheated, right? So let us again increase it to 10 megapascals. So if we heat it further, what you find is that again the latent heat, which is HFG, goes on increasing. Please note that the state B, state F, state G, all these states are saturated liquid. The difference is that state B is at 1 atmospheric pressure, state F is at 10 bar, and state G is at 10 bar. So all this saturated liquid means the liquid which is about to boil. If you join them, they would form a saturated liquid line. So this is a vapor dome which you see in front of you, a dome-like structure, and this loci, the points would be on an imaginary line which is called as a saturated liquid line, and it would have all the points on the saturated liquid line would be saturated liquid in the sense that if you heat it, it is about to boil, right? Similarly, state C is dry saturated steam at 1 bar, state G is dry saturated steam at 10 bar, and state K is dry saturated steam at 100 bar. Okay, if you join all these points, it would again be a curve, and it is called as saturated vapor line. So saturated liquid line means it would have all the saturated liquid as a state or phase of that steam, and saturated vapor line would have all the points on it as dry saturated steam. Okay, what you see as a straight line, horizontal line, represent the latent heat of vaporization. As you go on increasing the pressure, when you go on increasing the pressure at which the steam is heated, you'll find that the latent heat goes on increasing. It means that the boiling process, this J to K is boiling, F to G is boiling, and B to C is boiling. So as you go on increasing this boiling process goes on reducing. Okay, and at point N, which is called as a critical point, you will find that the latent heat of vaporization is 0. Now this is very interesting. This happens at about 221 bar. Okay, 22 megapascals means 22.09 megapascals means 220.9 bar. So at around 221 bar or at 374 degrees centigrade, which is called as a critical point, you will find that these two lines, that is a saturated liquid line and saturated vapor line, they meet. Okay, and when they meet there, what is the meaning of this? The meaning is that if you heat this water, if you design a boiler which is operating at 221 bar, you will find that the water will not boil. Then what would happen to that water? The water would suddenly flash to steam. So there would be water and then there would be steam. There is no boiling. Boiling, you understand that when you, for example, if you take an open vessel and if you, for example, when you are preparing tea, how do you prepare a tea? You take water in a container, and if you go on heating that water in that container, what happens is that the bubble formation happens. So that bubble formation, when it reaches 100 degrees centigrade, is called as a boiling phenomena. That is, there is a phase change. Okay, once it reaches the boiling point, there is a phase change. So this kind of phenomena of boiling is not seen when you are at a critical point or at a pressure which is above the critical point. So in modern industries, in larger thermal power plants, modern thermal power plants, you'll find that the boilers, they are no longer called as boilers because there is no boiling. They are all supercritical boilers in the sense that they would operate at a pressure which is greater than 221 bar. Okay, but your regular boilers, for example, in process industries, you would find that the boilers are at a pressure of 10 bar, 100 bar like this. Okay, so this we need to understand clearly. So in this steam, when you want to study the properties of steam, this understanding goes hand in hand. That is, this terminology along with how to use and how to refer to the steam tables has to be simultaneously understood. Okay, so let me now show you the steam table. Okay, so you can use any steam table, but I have taken an example of a steam table which is published by R.S. Kurmi, S. Chand publication. Okay, so if you look at the steam table, what you'll find is that it is the steam tables are available in different units, but we would be using the steam tables in SI units with the Mollier diagram. Okay, so if you just go turn your pages of the steam tables, what you would find is that very interesting information is that. Okay, let me go to that information. You'll find that there are about 3 tables which are of practical use. One is the saturated water and steam table. One is saturated water and steam table. Now, what is the difference between table 1 and table 2? Table 1 is a temperature table and table 2 is a pressure table. Actually, table 1 and table 2 are the same. Table 1 and table 2 are the same in the sense that both the tables would have the same properties. Only difference is that in one table, the properties are arranged on the temperature basis, and in the other table, the properties are arranged on the pressure basis. Okay. So how does a saturated water and steam table look like? Okay. So this is a typical representation. What you'll find is that in the saturated water and steam table, the first column is the temperature column. The next column is the corresponding pressure column. Now, what is this corresponding pressure? What I mean is that the corresponding pressure is called as the saturation pressure. What do you understand by saturation pressure? You know that water boils at 100 degrees centigrade if the pressure is 1 atmospheric pressure. In our terminology, we would say that the saturation temperature of water is 100 degrees centigrade if the saturation pressure is 1 atmospheric pressure. So that is the meaning of the saturation pressure term. Okay, so the first column is the temperature and second column is the saturation pressure. It is the absolute pressure, mind well. The tables, the temperature is given in degrees Celsius, the pressure would be in bars. So what does it show? When the temperature is 10, the pressure is 0.01227. The meaning is that if you want the water to boil at 10 degrees centigrade, the meaning is that if you want the water to boil at 10 degrees centigrade, you need to reduce the pressure to 0.01227 bar. Okay, if you want the water to boil at 0 degrees centigrade, okay, now you know that it would freeze actually, but let us say that if the water has to boil at 5 degrees centigrade, the pressure is 0.00872 bar. Okay, that has to be the pressure which has to be maintained. The other properties which you find in the steam tables are the specific volume. Now, a very interesting thing is seen in this table. You look at the specific volume of water at 10 degrees centigrade. The specific volume of water is 0.001. And what is unit? Meter cube per kg. Okay. So, VF. F is what? F, as I said, refers to the saturated liquid. So, VF is the specific volume of saturated water. What is saturated water? Saturated water is the water which is about to boil. Vg, what is Vg? Vg is the dry saturated steam, specific volume of dry saturated steam. So if you compare the specific volume of liquid water with the saturated steam, you will find that the specific volume of the saturated steam is many times, okay, and you just take the ratio of 106 by 001. Okay, you'll find that many times is the increase in the volume during the phase change. Okay, So during the phase change, there is a tremendous increase in the volume. If you go on heating the water at, let us say, at constant pressure, right? The water would experience a tremendous increase in the specific volume, which is shown in the table. Look at the column of HF. What does HF tell? HF is the specific enthalpy of saturated liquid, saturated water. And what is that unit? The unit is kilojoules per kg. So HF is the specific enthalpy of saturated water. Its unit is kilojoules per kg. If you heat it, you know that there will be a phase change, okay, and it would become dry saturated steam. So when it becomes dry saturated steam, its enthalpy becomes Hg, which is 2519.9 at 10 degrees centigrade. Okay, and what is this 2477.9? If you just take a difference between 2519.9 minus 42, if you do this difference, you will get this term. And what is this term? This term HFG is nothing but the latent heat of vaporization. What is latent heat of vaporization? Is the amount of heat which is absorbed by water, saturated water, to convert itself to dry saturated steam. Right? Another interesting property which you would find in the saturated water and steam tables is the specific entropy. Look at the unit. It is kilojoules per kg Kelvin. SF is the specific entropy of liquid water. SG is the specific entropy of dry saturated steam, and SFG is the entropy change during evaporation, that is during phase transformation. Okay, so this becomes very handy if you know the temperature, then you can find the corresponding saturation temperature, specific volume, specific enthalpy, and specific entropy from the steam table. Okay, so these are called the temperature tables. What are the pressure tables? Pressure tables are the same. What you see is that instead of the temperature as the first column, you will find that the saturation pressure is the first column. Then the corresponding temperatures are given, and then the other properties are marked. Okay, so it is same. For example, if you take the pressure of 0.01 bar, at what temperature would the water boil at 0.01 bar? The water would boil at 6.98 degrees centigrade if the pressure is a vacuum pressure of 0.01 bar. What would be the specific volume of the water at that pressure? If it is saturated water, then it would be 0.001 meter cube per kg. And when it converts to steam, its specific volume will increase to 129.21 meter cube per kg. What would be the enthalpy of the saturated water? At 0.01 bar, it would be 29.3 kilojoules per kg. How much would be the latent heat required for converting this liquid water to dry saturated steam? It would be 2485 kilojoules per kg. What is Hg? It is the specific enthalpy of the dry saturated steam at 0.01 bar. Similarly, the entropy of dry saturated steam at 0.01 bar is 8.977 kilojoules per kg Kelvin. Okay, so now we realize that the first two tables, that is the table 1 and table 2 of saturated water and steam, they are the same tables. Only difference is that the one table is arranged on the temperature basis, the other table is arranged on the pressure basis. Okay. Now, third important table is called as the superheated steam tables. Okay. What do you understand by superheated steam tables? Superheated means what? Superheated means the temperature of the steam is greater than the saturation temperature. Okay. So let me show you the superheated steam table. Let me first just scroll this saturated tables. Look at this. Table 1, saturated water and steam. It is arranged on the temperature basis. You look at this 0, 1, 2, 3, 4, 19 degrees centigrade. Let us take 100 degrees centigrade because you are familiar with 100 degrees centigrade. Let me quickly move to 100 degrees centigrade. Look at this. This is 100 degrees centigrade saturation temperature, and you will easily notice that the pressure would be 1.013 bar, okay, which is the ambient pressure. If you go on increasing the pressure, if you increase the pressure from 1 bar to 1.8 bar, the boiling point increases from 100 to 118. Okay. If you increase the pressure from 1.013 to 1.86 bar, the boiling point of the water would increase from 100 to 118 degrees centigrade. Okay. This is very important understanding. Now let me go to the this is a pressure table. Again, I will show you the 1 atmospheric pressure because that is what you are familiar with. Okay, this is the 1 atmospheric pressure, 1.01325 bar, and you can easily now predict that the saturation temperature is 100 degrees centigrade. Okay, if you have a boiler which is, for example, the pressure cooker has got a pressure of 1.2 to 2 bar, you'll find that the temperature of the steam in the pressure cooker could be 106 up to 120 degrees centigrade. Okay, so if you go on increasing the pressure, the boiling point would go on increasing. Okay, if there is an industry which is having a boiler of 10 bar, at what temperature would the water boil? So if you have an industry which is having a pressure boiler which is at 10 bar absolute, then the water would boil at around 180 degrees centigrade. Okay, the water boils at 180 degrees centigrade. Okay, and let us now look at the critical point which is 221 bar. Let me show the point where the steam table ends. Okay, so this 221 bar, you see, at 221 bar, the critical, which is the critical point, critical pressure 221 bar, the critical temperature is around 374 degrees centigrade. And look at the latent heat. The latent heat of vaporization becomes 0. Okay, so what is critical point? Critical point is 221 bar, 374 degrees centigrade, and it is a point where the latent heat of vaporization becomes 0. So now if you heat the water below 374 degrees centigrade, if you heat it at 380 degrees centigrade like this, then it would be a supercritical boiler. Or if you have a boiler which is operating at 250 bar instead of 221 bar, it would have, it is called as a supercritical steam generator. Okay, supercritical boiler. That is what it is. Similarly, the tables for specific volumes are shown. If you are interested in knowing what is the specific volume at 0.02 bar, you can read. Now this, okay, so table 3 now. Now table 3, from table 3, you'll find that it is a superheated steam. Okay, and for superheated steam, it is not enough to simply know the temperature. Okay, we need to know two things. We need to know the pressure as well as we need to know the temperature. That is the reason why we have the tables arranged in this fashion. For example, if the steam is superheated, and we'll take a familiar example. We'll take the pressure of atmospheric pressure so that you'll appreciate what I mean to say. If you take a pressure of 1 atmospheric pressure, let me go to 1. Okay, this is 1, approximately 1. So you know that at around 1 atmospheric pressure, the boiling point is around 100 degrees centigrade. Okay, let us say that the steam is at around 1 atmospheric pressure, and the steam is superheated and its temperature is 150 degrees centigrade. 150 degrees centigrade. So at 1 atmospheric pressure and at 150 degrees centigrade, if you go straight up to 150 degrees centigrade, you will find that this becomes your specific volume, 1.936 meter cube per kg. Okay, so this way, by knowing the pressure as well as temperature, if it is a superheated steam, we need to know both the pressure as well as temperature. If it is a saturated steam, if it is a wet steam, if it is disaturated steam, then it is enough for you to know only the temperature or pressure. Okay, that you need to understand clearly. So for superheated steam, generally you will find that this way the properties are arranged. You will have specific separately mentioned. You will have specific enthalpy separately mentioned for superheated steam, and you will have specific entropy also separately mentioned in the superheated steam. Okay, some tables, some steam would have all these three together. They would put all these three values, that is specific enthalpy, specific volume, and specific entropy in a single chart. Okay, so whatever is the method of representing, what has to be clearly understood is that when you talk about superheated steam tables, then you need to refer to both the pressure as well as the temperature of superheat. Okay, and that is very important for you to understand. I hope this is very clear to you.